Is your family ready to fire you over your poor network administration skills? If you're killing your internet too often with things like virtualized firewalls, if so, I've got a good solution for you today, and this is going to be a little bit simpler than the route you may be taking. And at the end of this, we're going to have an unkillable internet router. Whether you're using 1 gigabit or whether you're using 100 gigabit, we're going to be setting up our virtual firewall instance in OPNsense. You could also use pfSense most likely for this with some adaptations, but OPNsense is great for virtualizing in Proxmox right off the bat very easily with just a few tweaks because of the addition of QEMU agent inside it very nicely. This is exciting, and I hope that I can help you get through probably one of the more complicated tasks out there that you may have ran into, which is making sure your internet is highly available and your routing is highly available throughout your house. So while we have all the way up to 100 gigabit networking on our switches, we also have 1 gigabit connections on our switches as well. While the 5548P is an older unit and something that I will be replacing in the very near term, the SN2700 100 gigabit network is certainly a very modern switch and capable, of course, of that 100 gigabit Ethernet traffic. So right now, currently, we have the OPNsense machine, and this is essentially a bare metal instance of OPNsense. Now, by virtualizing it, we are able to put that on multiple machines. And since that cluster is a highly available cluster in Proxmox, that's going to give us the ability to have VM shift around. What we have done here, there are some janky things. If you're noticing here on the networking, there are some janky things. We're going to get that addressed. And so we have 100 gigabit network connectivity on this machine. We also have 100 gigabit connectivity on this machine. We also have 1 gigabit and 2.5 gigabit connections on this machine and this machine as well. So I'm going to show you why this configuration is split up the way that it is. If you see here, you can see this one routes over here. This is on the to-do list, of course, and cleaning up this wiring and that placement is definitely something that has to happen. But this is one of the things that allows this to happen, that extra switch over there. Tiny Netgear, 8-port, not really great unit. And if you see here, it's blinking all at the same time, all in unison. This is because this is an L2 switch. It's broadcasting all ports all the time. And this is connected to our network modem. Here we've got our cable modem with its defective Puma 6 or 7 chipset on it. So these two ports on these two different machines that are 100 gigabit cards are connected to the SN2700. These two ports, even though this one's nicely routed and this one, the green one, is not nicely routed, are connected to the networking switch. And in the DMARC, we've got one of our Zima boards here. This is Zima board 3, and I'm going to show you the labeling of these so that you can see. I've written L and W, so WAN and LAN. This is connected to the small network switch that we've got. These are nice 2-port devices. This is also backed up with a battery system, so we do have extended runtime, and it's running this entire thing right now about 15 watts. So one thing you can do to turn a dumb TV into a smarter TV is place an SBC on it and then use that as a connectivity option. I decided to double duty. All of my TVs have this at the back of them, a Proxmox machine running on this Zima board, which is actually not surprisingly bad performance. If you'll note, they all do have a SSD attached to them. This is a valid block storage device for Proxmox. You could use the internal MMC, but that is not recommended, and it's also very slow, very non-performant, and we are actually hoping to get a little bit of performance out of this system. So even this is actually doing double duty right now, since it's always on and since it uses like about 11 watts or so when it's actually running. That's not a bad amount of electricity to be using. I'm fine with that when we're looking at it keeping the internet up and providing redundancy as a quorum device. As a matter of fact, I have 3 of these Zima boards running right now providing quorum. At my command center in the garage here, you can see that I've got OPNsense running up here, doing some networking, charting, so that we can see that the connectivity of it is looking really good right now. We also are playing a 4K video at the same time. I've got over here on the screen our Proxmox interface, and then up here you can see that we're running a ping with a T command on Windows to be able to provide us with continuous feedback on how long a disconnected state or latency might be impacting that particular machine. This is pinging, of course, that OPNsense VM 192.168.1.1 in this instance. So now that we've talked about the hardware, let's take a look at the software side of things. This can be a cluster on any type of a computer. You do not need high performance networking for this to still be a really performant and really impressive system. So I'm going to go ahead and start a ping with the -t command, and that will give us a non-stop stream of pings. 192.168.1.1 is the identity of the OPNsense box here. And if we go to Proxmox, we can see that it is currently living on Prox4. This is one of the Zima boards. Now, you'll see that I am in the replication settings menu here, and I have added replication targets for this particular node. And if you look, I've also set this at 1 minute synchronization for those. Now, I think I can shrink this here and we'll be able to see a little bit more information on this side. So you can see the next sync is scheduled for just a minute, and it'll sequentially run through these. And each one of these, it'll give you a duration for how long it's taking. And of course, the faster machines are going to finish incredibly fast, and the slower Zimas are going to take a bit longer because they're not on as fast of a network. And we'll see that when we actually migrate the VM around here that has OPNsense running in it. This is not an ability to radically unplug, to uncontrolled shut down your OPNsense or your cluster. As a matter of fact, if you do that with a cluster, it's going to be a cluster something. And you're going to have a lot of work to get that back into a state that's good. So, of course, backups always, but at the same time, you should not be shutting down your clusters. The reason you're doing this is so that you can, in a controlled fashion, if you shut down a device, have the VMs migrate automatically. And so we're actually going to do that right now. And so as you note over here, we've got our pings to this. I think it might even be interesting if we go ahead and throw up a second tab, and I could ping external website or something, possibly, if they don't ban me, which hopefully that doesn't happen. Let's see here. So we'll ping my website. I'm probably not going to ban myself. So let's go ahead and shut down this node. Now, I'm not going to actually tell it that I want to migrate ahead of time, just like you might if you actually forget. But the settings that we have in place are going to automatically handle that for us. So that's a really nice thing. And that happens in this settings menu, your options this. So you can see our HA settings are set to failover. I would recommend going with either migrate or failover. The default is conditional. I'm going to go with migrate so you can see what I would recommend you set up. The behavior is if you shut down a machine without, doing a manual migration first. So we'll come to this and we'll just click shut down. And let me shrink this a little bit so we can see those a little bit better. And if you look down here, you're going to see some information coming across as soon as it processes that it needs to move this, and it'll throw this up. Bulk shutdown VMs and containers have been received. So after it receives that, it's going to check its policies. It's going to see that it has a migration that it needs to do to this VM. And if you had, of course, other VMs, that would start doing that as well. And so it's going to start it when it moves it back to Prox 0, and it's going to do the migration. So you can see the migration is underway here already, and it should be done in just a few more seconds. But I think the most important thing to note is that we have no breaks in our connectivity over here. We might have a millisecond or two that time out, but that's it. And considering we're coming from a gigabit device, that's actually pretty impressive. And that's not going to break your tables. That's not going to require you to refresh or anything. So we can now see that this is actually a host that is offline. I'm going to show you the steps to manually migrate this, and we're going to migrate it from Prox 0 to Prox 1. So by clicking this, we can see Prox 1 is selected here. The mode is automatically going to be online. And while it'll throw up this warning, we effectively know that it's going to happen pretty quick because we already have synchronization that has happened. This gives you an ability to take machines offline. This gives me the ability to take more power-hungry machines offline, or machines that might not have as much battery capacity, especially for runtime.
offline and have it run on things that have great battery capacity for running for long periods of time. The Zimas use right around 15 watts. The R5 3060, so that's Prox 0 and R5 3060, if we take a look here at the summary, is going to be somewhere in the neighborhood of about 45 to 50 watts. The Prox 1 machine, a 5955WX, with 256 gigs of RAM and actually chocked full of hardware, I mean, absolutely loaded up with hardware, this thing is going to be quite a heavy load on a UPS for extended run times. So I do not want Prox 1 to be, utilized for running the network if I anticipate I need to shut it down. The things that I keep on it, I want to have high availability of, but I want to be able to move those off pretty quick. Of course, like I said, make sure you have backups. I prefer to have a remote TrueNAS machine that is bare metal that I can back up to and from, and it can also power things like ZFS over iSCSI and a lot of other cool stuff that we're not going to deal with here. If you're really astute and you really wanted to set something up that is resilient, you could even go further than this on Proxmox by setting up a Ceph cluster with 3 devices, and you would get really great IOPS on it for things like reporting or recording or IDS functions, antivirus functions. If you were running a business or something, possibly that might be useful. But that would give you a really good capability to have hard unplugs. So that's really what you want to go with if you want the ability to have a machine essentially crash out, fail out, and the machine the VM automatically start up on another machine. That's not what we have here. I personally am not going to set up Ceph on this because I think that's a little outside of the scope, but there may be some machines that do have Ceph on them in the same cluster. So make sure you hit like and subscribe so you can follow along with those things. Now, let's take a look. We've already checked out replication at some of the data center things that we've got going on. So of course, replication here, but down here is the other important thing, high availability. And so before you're able to actually add resources, you need to create a group. So we created a group called router. And if you double click it, it'll pull it up here. And you can see that we have priorities assigned. And I also have a box ticked, which is not ticked by default, which is no fail back. Do note that your priority is essentially not what you might think if you're thinking, 0 is going to be the highest priority. Whatever the number that you have is, that'll be the highest priority. So we have 5 here. 5 is the highest priority here for then 3, 2, 1. And that works out really good. You can see 3 here is offline right now. So if we were to fail out 2 more machines, we would not be Core 8. So we would have a different problem. So keep in mind, you cannot fail out an infinite amount of machines in this scenario. You really do have to have, in that instance, if you want to stay up and running, a separate device that is a bare metal installation of OPNsense that you do have a quasi-carp setup or a full carp setup running through. That's different than this. This is really good. This is going to suit most people that already have a Proxmox cluster or can create a Proxmox cluster very well. But this is not uncontrolled crashes and shutdowns level of protection. If we go over to HA after you have created your group, it will bring up when you go to create a resource, a VM that this one's 100, of course, as you can see here, VM ID 100. This will not be populated right off the bat. So we added that in. We selected the group. So from the drop down, we can see that we've only got one group here. The requested state is started. So you can have it migrate in a stop state. We have it in a started state. I don't know what ignored or disabled do, but I'm not going to find out necessarily either. Max restarts. This one is important. If it fails to start, will it give it a second shot? I think it's a good idea. Max relocate. How many times do we want to relocate it in the same cluster? So I think a good idea here is to set it to whatever the total number of participants are in the group. In this group, we should have 5. Let's make sure that we've got 5 over here in this setting. Yes, we've got 5 over here in this setting. So I'm going to change that over here to be 4. So that way it will try throughout the machines to see if it can get it going on one of the other ones, if it's not able to start on the machine that it's been moved to. So you might be wondering, what changes did I make inside of OPNsense? Let me tell you, not many. As a matter of fact, I think this is going to be really easy for you. So go through the default setup steps, VTNet 0 and VTNet 1. So these are important for you to set. So go ahead, choose manual assignment, set those, and make sure that that's consistent throughout all of your machines, because that setting right there will be a deal breaker. So in each one of these, net 0 device is going to be the LAN. Net 1 device is going to be the WAN on every single one of these. And that is important for you to have as well on your configuration. That might take a little bit of mapping if you've got a lot of ports, but that doesn't take terrible amounts of mapping if you only have a few. So on the Zima boards, for instance, Prox 2, Prox 3, Prox 4 here, we've only got 2 ports, EMP2SO, which is the LAN device, and EMP3SO, which is the WAN device. And you can see that the initial one that you set up during your installation of Proxmox on a machine is going to come in as this VMBR0 device. On other devices, you may have to actually create a little bit of a chart and map them down so you can actually say which one of these network devices belongs in which one of these, because that may not be consistent. What does need to remain consistent is that your 0 and your 1 are your LAN and your WAN. That you can certainly have multiple other interfaces also, so don't feel like you can only have this one interface, but definitely VMBR0 LAN, VMBR1 WAN. Now the configuration follows the individual VM around. Conceptually, that might not be something that makes sense unless you've seen it in action before, but the settings you have here are going to translate to there. And so if you have, say, 16 gigs of RAM or 256 gigs of RAM or 4 gigs of RAM, you need to have this fit inside that footprint. As well, the instruction set flags that you have need to make sure that they are going to work. So when you set your type of a machine, the microcode improvements that are out there right now are really good. The Zima board is not capable of V3, although the Ryzen R5 3600 series is capable of V3 as well. Of course, the Threadripper is capable of V3. You do see performance improvements with that, but this is life and such is life. So do set that to as high as you can go. You do need to set it to a QEMU type. So this does need to be one of these QEMU types here. And you do need to have emulated network devices. If you did do PCI pass-through, it is possible to map those devices, but it is extra steps and we're not going to cover those here. Comment down below and let me know if you've done that yourself though. The sockets that we've got is 1 and 4. So you would need to, if you have multi-socket systems and single socket systems, have that set to just one socket. So you could plan out your actual VM's migration groups at the same time that you're mapping. That is a pretty good way to do it. And I like to set it all the way up and then bump down the vCPUs. That way, on the fly, if you need to change the amount of CPUs that you have access to, you can change it from 2 to 3 to whatever. So this gives you that really nice capability to do that and have that kind of take on some instances. I'm not sure if it would take on FreeBSD, but I think it does work on things like Ubuntu and Windows. So that is pretty much it in a nutshell for the Proxmox side of it. Again, knowing what this does and knowing what this doesn't do is important. This does give you options for migrating. This does solve the I accidentally shut it down and forgot to migrate it. Most of the problems that I've created with the networking are of my own design in this house. So this does, in my opinion, have a very high chance of fixing that. So I don't think I'll be turning off the Zimas. It just doesn't seem like something I will ever do. And I don't think there's even hardware maintenance I could do on them if I wanted to. So those are going to be perfect little devices for this if you're good with the 1 gigabit networking speed that they have.
And so we have quite a few things on the to-do list still to wrap this part of the project up and call this a validated system. Namely, one of the things that I need to do is make things tidy like they are inside this box with the rest of this. Let's take a look at those outstanding items. And this is the epicenter of things that need to be cleaned up. I'm not exactly sure where I'm going to attach this small networking device. Everything that I have over here that's power providing is on 220. This is a 120 volt AC little unit. Also, the Zima boards don't have adapters that will serve for the rack. So I probably need to find an addition to that. some way of getting 120 volt AC that is on a UPS for this Zima board also. Zima 2 here, this is also Prox 2 for reference, but it cannot live on the step stool. I need to use the step stool for everything else, and this is definitely in the way. Having cables on the floor is a no-no that I'm not going to allow to have happen also. So the green cable that's running over there to Prox 0 needs to be ran up in the network raceway as well. And so we can see that Zima 3, also Prox 3, easy for naming schemes here, but this unit is actually UPS powered at this point. That is a fully backed up system. There are 2 other Zima boards, of course, that are not. One of the things that's high on my to-do list also is getting these out of these cases. They're very inefficient for this placement, and so having those into a real server case will really help things out. I still have analysis paralysis on this because I have actually talked to a lot of people that have been upgrading their EPYC and AMD and Threadripper systems, putting them into server rack cases with varying degrees of success. If you have suggestions, drop them in the comments below. Of course, the patch panel, this is actually turned into a really big issue. I've had 3 bad punches on it, and taking it off to repunch is a non-starter. So as people have suggested, I did go ahead and bought a different patch panel. So we do have pass-through capabilities for the Keystone jacks on that. So we're definitely going to be doing that. That is one of the things that is going to incur some downtime, I fear. So I need to plan that out a little bit better, but I'm also going to make sure that I get some quality cable that is color-coded. As you can see right here, I've been using tons of cable that is just a hodgepodge, really, of stuff that I had around. So I'm going to buy some cable, maybe Monoprice or something, that is actually the colors that I want so that I can pull the links I desire and terminate them as I see fit. You can also see we've got just tons of extra wires hanging out here. This is what I'm talking about. These things are easy to clean up. This patch panel, not quite so easy to clean up. So make sure you check your hardware that's going into it. Make sure you check your cables that are going into it. Pre-terminated cables are, of course, something that is going to save you a little bit of headache and hassle as you try and need to hit gigabit speeds at a minimum for this to be a really seamless process. I hope this is exciting to you, and I hope you can follow along and hopefully keep your internet working, even if you have a lot of machines down in your house. Everybody, this is Digital Spaceport. Be sure to hit like and subscribe. And we've got a lot more networking videos that'll be coming up shortly. I will check you guys out next time.